Hi Algebra 1 students. Today we are going to be starting a new project or new lab, and it's called Making a Move. It's actually about buying a new house, and in the first module it's called Learning the Market. And right here I wrote down, this right here represents basically what the prices of the houses are, housing trends, I should say, from 2010 or 2000 to 2010. And again, that represents this interval, years since 2000. Okay, this is the average home value in thousands. All right, and so sometimes if we have a quadratic function, we can graph it. We can also rewrite it in a different form. We're going to learn this form to quickly access information that we want, let's say maximum or minimum values. So that's what this whole module is about, finding the maximum, finding the place where the y value equals 0 on some of these. We're going to learn how to analyze quadratic functions. We're also, like I said, going to learn how to complete the square, and that will help us to be able to access certain information quicker. So on this first step, this is step 1. I know it starts with number 2, but it's actually step 1. This is all that we have to do on this one. It says label the zeros, also called solutions or roots, the max or min, and find the line of symmetry. So sometimes with quadratics, we're able to find what's called zeros. I'll do one with you, and then you can do the other one. Zeros are where this graph, this quadratic function, it's also called a parabola, where it touches the x-axis. So you can see here and here, it touches the x-axis. So you want to label those. Those are called zeros. Again, solutions and roots, they're all the same. Depends on what context you're using. So here, x equals 1. And over here, x equals, it's hard to see on this graph, but that's actually -3. Okay, this is like 0, -1, -2, -3. And again, this is just counting by ones here. So that's the 0 there. If you want to write it as a point, you could also put 1, 0. Okay, so it's where y is equal to 0. Here you could put -3, 0. Okay, so then it asks us to find the max or min. That's the highest or lowest point. Since our parabola is pointing upward, we actually have a minimum. Okay, so right here, this point right here, that's going to be your minimum, and that looks like it's -1, -4. So -1, -4 is our vertex, or our max or min, like in this case minimum. So we can label it vertex, okay? The last thing is the line of symmetry, and that's just if you were to split the parabola right down the center vertically, if you were to split it, where would that be? So you can kind of see, it's where it actually goes through the vertex. If we draw a straight line up and down through the vertex, that is our line of symmetry. Okay, and that line, it looks like if you look at the x value, try to look at the x value, that's going to be x equals -1. Okay, and that's a line straight up and down. That's represented by an x equals equation. So that's all you have to do for these. Okay, so you're going to try one that's pointed the other direction. So this one's going to have a maximum. Okay, and again, identify the zeros, identify the maximum, label it as a point, and the line of symmetry. Okay, next step. This is vertex form. So again, like I was saying before, sometimes you have to rewrite functions in vertex form. These are already in vertex form, okay? And right here I've written what vertex form looks like. So instead of, I guess, a function that looks like this, with no parentheses and all that, this is another way to write these quadratics. It has parentheses. It shows you really where the max or min, or the vertex, is. And you're able to identify it if you just look at these values here. So in this equation we have x minus h squared and then plus k. These two values, h and k, are going to be your values for your vertex. It's going to be a point. X is like, the h is like your x value, and the k is like your y value for the vertex. So if you look here, I'm going to write this function right over it so you can see where h and k are. So you can see on this example right here, h is equal to 3. So for my vertex, I'm just going to say 3, comma, and you can see k is equal to 5. So that's as simple as that. So 3, 5. I'm going to do one more that looks a little different. Okay. Actually, this one doesn't look too bad. We can actually go through a couple of these, but I'll show you these other ones too because they do have something slightly different here. So on this one, again, if I write this above it, you can see on here, not that we need to know this, but that a is equal to 5. Oops, should be an a. Okay, and then you can kind of see h, but if you notice right here, this is a plus sign. So we'll rewrite that so it looks like this equation here. So if I rewrite it as a minus sign, what would h have to equal in order for me to get a plus 2? If I rewrote this as x minus, then if I had a negative 2 in here, that would be the same as saying x plus 2. If I say x minus negative 2, I'm just rewriting it with a minus sign and a negative so I can really clearly see h. So if I do that, if I rewrite this equation, then I can see the values here. It's supposed to be a 1. So here's h, here's k. So negative 2, comma 1. K is just 1 because that's still a plus. If it's a minus sign there, then you're going to know that k is negative. All right, so for this one, I'll just at least show you how to rewrite it. So this looks, pretty normal, except it's just missing the k, and that just means it's a 0. There's a plus 0, and they just don't like to write that. So again, rewrite this with the minus sign, and again, you'll want to rewrite it as x minus some number. That number should, if you subtract that number, you should get a plus 6. So try that. And then on this one, you can see the k on the outside, but the h is missing. And again, that just means that it's a 0. So you can put it in parentheses and you can say x minus 0 squared minus 2. Okay, and then you can clearly see the h is 0, and on this one you can see that k is actually a negative 2. So for that one I can just give you, again, h is 0, k is negative 2, so that's the vertex on that one. Okay, so that's what you have to do for this step. You only have a couple to do on your own. Then, last part, if you learn how to factor, we're actually going to go through methods of factoring for this particular lab. Before you complete the square and try to rewrite a function into vertex form, you have to know how to factor using the greatest common factor idea. So all that is you're trying to think of the greatest factor or the greatest number, or I'll show you later, it can involve letters too, but the greatest thing that goes into all the terms. So if we look at this first example, what's the biggest number that divides evenly into 6 and 3? A 3 does. So if I bring that out in front, I can rewrite that out in front, and then I can think, what number times 3 gives me 6x? 2x. So I write the 2 in there. It's almost like taking the 6x and dividing it by what they have in common here. So 6x divided by 3, that leaves me with 2. And then I have my x attached to it. And again, you can think 3 divided by 3 is 1. Or you can think what number times 3 would give me 3, either way. But that is rewritten now, factored, in factored form, and 3 is the greatest common factor. And I've written it out in front. Okay. Next one might be a little different. There's still 2 terms, but notice they also have an x in common. So that's also going to come out. So if I look at the 2 and the 4, I know 2 goes into both of those, and I have an x in common. So I'm going to take out a 2 and an x. And then think about, maybe do it the division way. Think about 2 divided by 2 is 1. So you're going to have a 1 in here. You don't have to write it, but you're going to have it. And then if I take one of the x's out, here's 2 x's right now. That's going to leave me with 1 x left. So I put that on the inside. And then I put my plus sign, just copy the sign that's right here. And then think 4 divided by 2, that's 2. And if I take one of the x's away, that's the only x there. So the x's are gone in this case now. So we just have a 2, no x's. So now that's rewritten in factored form. So you're going to try to do these next 3 on your own.